want to know, how does the magical process of acquisition work? And so I primarily use quantitative methods like computational cognitive modeling to try to figure this out. And computational cognitive modeling, it's a tool, it's a technique that lets us explore theoretical ideas precisely, and in particular evaluate how well some theory we might have about language acquisition, in my case, can explain empirical data that we know about children's language acquisition. So for this tool, math is at the heart. And one main part of it is counting things, right? Or keeping track of things, relative frequencies, however you want to think about it, but in some sense counting. And sometimes we count a lot of things, but okay, counting, keeping track of stuff. And another part is principled reasoning, sensible reasoning, plausible reasoning, based on those counts. One example of this that seems to accord with human cognition is Bayesian inference, where your belief in some hypothesis or generalization based on the data is related to how much you believed in that generalization beforehand, as well as how well the data fits that generalization, right? But it's a way of combining these in a principled way. Again, human cognition seems to do this a fair amount. This is an example of a principled reasoning process that is involved in quantitative approaches like computational cognitive modeling. So, great, we're counting and reasoning. What do we count and reason over? How do we connect that information to language acquisition, right? Because at the end of the day, we want to understand something about language acquisition. So we can use computational cognitive modeling to encode a child's acquisition process very precisely. That is a theory about how things work, very precisely. And here is just one way to think about encoding a child's acquisition process. This is a way that I recently came up with in 2023. It's got a lot of stuff going on. I'm not going to go through all the details, but just to give you a sense of, there's a lot of stuff involved. One distinction is the difference between what's external versus what's internal to the child. So external stuff, we can observe things like what the input signal out there in the world seems to be for the child to learn from. External things like the behavior that the child demonstrates, things the child says, things the child does. We can observe that. That's external. Then there's all the internal stuff that we can't observe directly. We can't observe internal things like what the child's actually able to perceive and encode from that input signal. We can't observe internal things like any additional filtering or focusing or selective attention that there might be before the child actually learns from whatever that intake was. We can't observe how the inference process itself actually works, right? We can't see that. We can't observe internal things like what the child's developing knowledge and developing cognitive systems, like what state they're in. We can't observe how they impact all the other internal stuff that we can't observe. We can't observe how the child actually generates the output that we do eventually observe in the external behavior, right? Like there's all this stuff that we can't observe that's important for understanding the process. All of these parts are important for making the process of acquisition very precise. I'm sure there are others I've forgotten, but that's at least some of them. So in a computational cognitive model, we try to implement all those parts of the acquisition process to be the same as how we think they work in children. And so for some parts, we're going to be drawing on available empirical data, and maybe about the input signal that's out there, the behavior that the child is producing, and maybe what we know seems plausible for some of these other internal components. And then for the rest of it, we rely on the acquisition theory that we're trying to actually evaluate to fill it in. And the idea is, there's a lot going on, but let's see how this works for the acquisition of some knowledge about WH dependencies.